Okay, thank you Benoit for coming. It's really nice to have you over, because it's good. As you know, we started our project a long time ago, and it's good to have new people, maybe doing the same, maybe not, but it keeps us awake, and I think we can, we're all going the same direction, so it's good to be together places like this. I want to speak about the progress with our project, the microsurgical robot. You've seen a few presentations touching the subject. My name is Tom van Mulken, but this is a big team effort. Joran Bosmans is a student working hard now at projects. Ferry Schoenmakers is a software person who will do the robotic football in after a few presentations. So hang in there. Raimundo Cao is one of the genius minds who developed and thought of the concept, and René van der Hulst was my teacher, professor at our department. And of course it's bigger than this, but we can keep on going. So disclosures, this project is about 10 years old, and I didn't have any financial interest or disclosures, but it's going well and we're pushing forward, and like it was already said, we're getting more and more professional, we're growing. So I'm CMO of the new spin-off, which I'm very proud of. So it's called MicroSure, and the goal is exactly the same of this company as it was 10 years ago when we started. We want to create a new step in microsurgery by superhuman precision, and that's why it's so cool that Professor Kashima is here, because he's pushing it, but he's a human. So I think it's going to open a whole new era following this guy and then pushing further. So it's a combined effort of the Technical University of Eindhoven and the Maastricht University Hospital. And it started in 2007. I was a registrar of plastic surgery, and this is upper left, Professor van der Hulst, because the Da Vinci machine was in, and we're surgeons, most of them were male 10 years ago, and we're all boys, and these are toys. So he was just, everybody wanted to try this Da Vinci machine, so he did as well. And he did a free-flap deep reconstruction and used the Da Vinci to make the arterial anastomosis. And he did it, so it was nice, and we published it, that it was possible. But then when we were talking about it, we said, if we are realistic, this machine is much too big, it's too strong. I'm sorry, this is not something for microsurgery. But while we were thinking, we thought, okay, but robotics assistance in microsurgery, that's where the robot is really beneficial, instead of only adding costs. So then Martin Steinbuch's team came together with our team, and Raimundo Cao was looking at the operations. Just like Benoit said, Raimundo just looked at operations a lot, and that's what Professor Steinbuch said as well. And that's really good, I think, because you really are developing something from the need. So that's also why there was one presentation about why, how, and what. This is why, and I think that's the strength of our project as well. So we didn't copy the Da Vinci. We started from scratch, and we just started thinking, what do we need? And that was 2008. And Raimundo did most of it, and we were just talking to him, and we came up with this idea. Because the Da Vinci machine can do a lot of things. Telesurgery, just named by Benoit. It's endoscopic surgery, and it's robotic assistance. But it's 3D view. But we've got a lot of things we have it. Microscopes are doing better every year. 3D vision, perfect. Telesurgery, we don't need it. The surgeon is always next to the patient. We're not operating in space. It will be good sometime, but it's not necessary now. So, minimal adjustments in the OR, also something that's really beneficial, because if you use the Da Vinci, you need a whole new setup of the operation room. And we thought we should keep it simple and focus on the why, and that's the precision of the human hand. And of course we're surgeons, so it should be idiot-proof, so it should be user-friendly and easy to learn. And of course cost-effective. And all those combinations are the why. So, I went too quick. So Raimundo set up this system of a ring mounted to a microscope, with the robot attached to it. And whenever you use a microscope, there is a robot helping your hands. So if you magnify your eyes, you magnify your hands. And that's, in our view, what we need the next few years. So we started testing. He's been thinking and building in 2011, and in 2013 he made the machine, and we could try and start testing. And we did all kinds of studies, you know, track and trace, putting dots, drawing lines, just like Benoit is telling us, well, what's good, what's not good. Then we stepped up suturing vessels, and that was what Clint Boymans talked about yesterday. And we tried to score the robot versus the hand, we learned from all these steps, and we adapted the robot. And then we were that far that we said, okay, this robot is good enough, and we could prove it's good enough. So the Medical Ethical Committee approved us to start doing animal studies. And here in Maastricht, that's a big step, because there were a lot of problems in the press with, they did some studies on dogs in the cardiothoracic guys, are they still here? So there was big problems with press, and it was, you really needed to, you couldn't just try something. But the robot was good enough, and we made it. We even sutured vessels of 0.5 millimeters, because we started with aortas, but it went well, we kept on going down. That was 2015. And then in the last 2 years, Raimondo and his team worked on a next generation of a robot, and I'm very proud to state that we're already there. There is a Gen 2 platform, and you already saw it. It changed. It didn't change in a big way, but there are a lot of things that we changed. And nowadays, this robot is capable of 360 degrees, full range of motion. We're designing it now for lymphatic surgery, and we already have sterile drapings and interfaces built up with the S&T super microsurgical instruments put in. So I think we've really made big steps pushing forward, and I'm able to present it, and I'm able to be your host, which I'm really honored to, but this is a big thing with a big group behind everybody helping out. So surgeons, our staff, also patient organizations and health insurance companies. We're talking to our project, health insurance and regulatory bodies. We are going to CE approval and talking to medtech partners. That are the partners that Professor Steinbuch was talking about, and after me, Martin Bailey will talk of one of them. So this is not me. This is a technical person. Martin, you saw in one of the movies, you said it was me. It was Ferry. This is Ferry too, and I think this is much more powerful than looking at me doing this. So Ferry was suturing a 2 millimeter silicone vessel, and the magnification is not so strong. It's 16 times. So it's in the lab. It's not the most fancy microscope, but I wanted you guys to show you that something about this new machine, and I think this is a nice example of that it's possible, and that we accomplished a new step. So what is our plan? The plan is to start with lymphedema surgery. Shan Q, she already talked about lymphedema, very small vessels, but it's under local anesthesia, and that's low risk for patients, and that's an ideal way to go if you want to try super microsurgery. And I really thought we need to have a high difficulty, otherwise you cannot prove the robot is better. So in plastic surgery we've got more studies already set up, but as said, you know, it's a team effort, and I think that's why RAMSES is so important too. We are a team, like we're here too, and I think we should collaborate. And so we need influences from maxillofacial, neurosurgery, urology, anybody who's got the ideas, just push it further, because I think that's where the innovation will come from. It's not a personal thing, it's just thinking ahead. So we want to set up multi-center trials in a broad field, and just try to get a very good robot that gives us more opportunities. So anybody who's welcome, join us with the next step. Thank you.